I have very little time, so I'll be very brief. Antmicro is around since 2009. We're working on helping our customers' systems, starting with ASIC design, FPGA design, software development. We do a lot of hardware design and other topics I'll mention in a second. We're one of the founding members of the RISC-V International. We're part of the RISC Chips Alliance. We're maintaining RISC-V and Zephyr. We help people build complex systems, and we help them understand these systems using our open source tooling. We develop machine learning and AI frameworks and help people deploy their solutions. And we help them understand the complexity of the systems and understand the relations between components and the dependencies. I will claim that development for space is difficult. You might not agree. Obviously, the costs are high. The hardware is difficult to produce, and it takes a long time to iterate on it. Testing of the software with the whole setup is naturally difficult. You will not give every software developer a whole satellite on their desk, and you very rarely send them to space to test their software in real-life conditions. So here comes Renode. What is Renode? Renode is a full system functional simulation framework, fully open source, as many of the tools and frameworks and products that we create. It allows you to run the same software you would put on hardware, and you can create very complex setups, heterogeneous, multi-node, multi-core within the single simulation environment. You can simulate sensor input to verify real-life conditions, and it's permissively licensed, so you can use it in every setup you'd like. As I said, you can simulate systems on different levels, so you can just focus on the CPU itself. You can focus on the whole SoC, so taking the peripherals around the core into account, but you can also look at the whole board, so with the sensor input and connectivity, and in the end you can simulate multiple systems connected together over various means. Since we are simulating whole systems, there is no notion of a simulation target for completion. You take the same binary you would use in production, and but you also, since you have full control over the system, you can either focus on running the full boot flow and simulate all the complexities, or you can cut some corners if you feel like it. The idea is that you don't want to test each component, each subsystem in separation, but you want to be able to test both the business logic, both the connectivity and the hardware access layer in the same go, not to be surprised by problems of integration later in the project. And while we are here talking mostly about RISC-V, Renode also supports a whole range of ARM cores, but also PowerSpark, MSP, and others as well. And you can mix and match. You can use our text-based formats to define your platform and create heterogeneous setups. And you can, one of the most important aspects is that you can rely on determinism of execution, even in multi-node with some connectivity between the components. Apart from, of course, running the software, if you're running in simulation, then you are allowed to have deeper understanding of the software you're running. Debugging is, of course, a feature that everyone uses, but you can also get a lot of information from traces generated in Renode without additional code instrumentation. You can script the reactions to specific events. You can trigger events on your own. So if you'd like to have a fault injected in your peripheral on your memory, that's fairly trivial with Renode. So where Renode and RISC-V combine. We've been working on RISC-V in Renode for a very long time. We have been working on it also in collaboration with Microchip. Back in 2017, we started working on the support for their Pulsar SoC to have it available as a model for their customers as part of their IDE, even before the hardware was widely available. But of course, since then, we've been developing constantly. Right now, we have broad support for various extensions. We have custom instruction sets. We can you can define your own instruction set if you like, and it has been very broadly tested in various applications. Of course, as I said, we focus on whole systems, so you can simulate actual platforms you find on the market, but you can also easily create your own as well. Yeah, and to circle back to how Renode is used in space application, we are happy to have more and more interest in these areas on very different stages of development. So even some companies are using Renode when they are still developing their hardware, so the software development can follow the hardware development very closely. Some are already have their hardware and they would just want to test their software very thoroughly rather than running on real silicon. And some, even after the launch, would like to verify if the next update of the software they send will not break their system that's fairly far away. As I mentioned, we have support for integration with sensors, so you can either just populate the sensor data the way you like to populate it, or you may integrate it with some external simulator that would, for example, calculate the environment specifics and details of the that are observed by the sensors themselves. You can integrate with and we have been working with the setups where Renode was integrated with various space-specific tools. Basilisk is one that I can name drop here for astrodynamic simulation. And of course, if you see a place, some specific tool that you like to integrate with Renode, then definitely reach out to us. As I mentioned, Renode allows you to understand your system better. So especially if you have very complex system that you'd like to simulate completely, that's a good framework for you. But it also allows you to select what you mostly care about. So if you feel that you're mostly interested in some part and you can mostly ignore the others, you can definitely mock them. You can have fast functional simulation of most of the parts of your system. And if you care for some components to be simulated in more detail, you can integrate directly with RTL. All right. So that's it from me. Thank you for your time. And if you have any questions, feel free to reach out.